friends. We're going to do some work today on our lesson 27 packet. And the first problem we're going to do together is problem number 4. This is a good problem because it's going to actually practice part of what we did in lesson 26 and some of the new stuff here in lesson 27. We're going to use f prime to indicate whether f is increasing and decreasing. We're going to use f prime to indicate where f has any minimums or relative minimums or maximums. And then we're going to use f double prime, the second derivative, for concavity points of inflection. So this is an f prime problem, this is an f prime problem, this is an f double prime. Okay. So if we start off with our f of x as x cubed minus 12x, that means our first derivative will be 3x squared minus 12. Now, for both first derivative tests and second derivative tests, the beginning of the problem is to, once you get the derivative, find the zeros or the roots for that derivative. So once I set 3x squared minus 12 equal to 0, I would think about this using a little bit of factoring, but you have other algebra options you can do. Ultimately, you get x equals negative 2, x equals 2 for the critical values out of the first derivative. Nice thing about a video is that you can always stop it, pause it, rewind it, and adjust it to your speed. So, increasing, decreasing, relative or local extrema, both of these have to do with whether f prime is positive or negative around the critical values. So for both of these, I'm going to look at a number line where I'm going to document the sign of f prime in the intervals around my critical values. I'll use my f prime equation as I'm thinking about this, which I can use in that form or in that form. The easiest number to plug in probably is the one in here. If we use like an x equal to 0 and I plug a 0 into 3x squared minus 12, that is going to be a negative result. So all the results for f prime when our x's are between negative 2 and 2, all those results are going to be negative. Once I get bigger than 2, and I think about something like this, well, if I go bigger than 2, like a 5, 5 squared is 25, times 3 is 75, minus 12, definitely positive. Nice thing about this one is having the squared, you're going to get the exact same result in this case, since you just have a squared variable and no other variable in here. Negative 5 is going to have the exact same effect as a positive 5. So that's an indicator of the behavior of f prime. F prime is positive and then negative and then positive. So I can answer questions A and B based on that number line. Having the number line itself is not enough. You have to tell the reader, tell the person looking at your paper what information you are determining based on what the number line looks like. So here's what I know. I know f is increasing on the interval from negative infinity to negative 2 and on the interval from 2 to infinity. And I know that because f prime is positive, or f prime is greater than 0 on those intervals. Now I've written a lot of work in here, so I'm going to have to squish my answers. I know, so that's one thing I know. Second thing I know that f is decreasing on the interval from negative 2 to 2 because f prime is negative. I'm going to kind of block this out. Oops, I'm not going to have enough room to write conclusions. I get a relative maximum anytime I go from increasing to decreasing. Increasing to decreasing makes a max. So I'll say that F has a relative max at x equals -2, F prime changing positive to negative. And then similarly, F has a relative minimum at x equal 2, F prime changing negative to positive. I know that's a lot of writing. It's a lot of work. These are typically for response questions. So we are going to be looking at a lot of elements of this. Your analysis, your first derivative, your zeros, your analysis tools, how you're justifying your conclusions. That's all work from lesson 26. In lesson 27, we then went into the F double prime. So let me do this for a second because I never have enough room. You know that. Oops, where's my screen capture? Oops, okay. Apparently I say oops as much in video as I do in person. Okay. So there's my F prime. So F double prime is going to look like that. F double prime is always going to be a degree less than F prime if we're doing polynomials, so we tend to have less critical values when we have lower degrees. No difference in this case, 6x equals 0, so x equals 0 is our critical value. Okay. And what we're going to do here is we're going to create or come up with the results of second derivative tests. Just like in first derivative tests, I can use a number line to organize my thoughts. I mark my critical number, in this case just the critical number 0 on the number line. I think about my second derivative. A negative number plugged into the second derivative will make a negative result. A positive number plugged into this second derivative will make a positive result. Everything's in the statements. This tells me F, the F function, is concave down on the interval from -infinity to 0. How do I know that? Because F double prime is negative. I know that the F function is concave up from 0 to infinity because F double prime is positive. And the change in concavity creates what is called a point of inflection. And even though we say a point of inflection, we still typically only give the x value. So I have a point of inflection at x equals 0, F double prime changing sign. Okay. So the analysis of the second derivative equation, pulling the critical value, creating the number line, doing the analysis, was one of the things we learned in lesson 27 at our last class.